Alright, I have done what I can with the foundation plan for your proposed building out here. I'm assuming that I have this location right on 571. But I took a look at the soil. To start with, I just took a look at the soil from the soil place. I'm assuming you're going to build somewhere in CRA. Obviously, there are plenty of buildings there that are doing just fine. So you could take the rest of the rest of this soil information however you like, but it is what I found. That CRA is Crosby Silt Loam, and this is sort of its thing. One of the concerns apparently with this soil is the depth to the water table, which puts it into a classification not suitable for building. But as I said, you could take that based on what you have built out there already. Corrosion of concrete is fairly moderate, so we're good there. And then this is the rating. They rate these soils based, and the person can take time to read this if they like, but it's pretty much, the soils are rated from 0 to 1 based on how good to bad going up. And this one here you can see is in the red zone, and mainly it's because that depth to saturated zone puts you in this very limited rating for the only small commercial buildings was all I could find that was close to what we were going to do, what you're going to do. I will say this, that I did locate this, that this soil does respond well to tile drainage. So given those two, given the fact you've got buildings all over the place out there already, and given this rating and what they said the problem is, I would recommend some sort of decent drainage if it's possible given your topography out there. In terms of the foundation design itself, this footings and pedestals at the column locations, this is how I calculated my areas and my weight, my loads on these. These are the data from the building manufacturer. They rate their snow, down rate their snow. I did not, and so when I designed this, I used these higher numbers. If it conflict, this one's pretty close, but generally if the number was higher, I used that to make my footing requirement calculation. But given that the engineer was talking about a 5-foot pad footing for these C columns anyway, I kind of used that as a guide. But I did want to note that once I calculate these loads on all these locations up here, and it's a mirror down there, that smaller square is actually what would actually be required based on the 1,500 pound soil bearing capacity. But if we extrapolate that 5 foot that we were talked about at the first point, we end up with this. So these are substantially larger in terms of bearing area for a footing. These are substantially larger than what would be required normally by the loading. That said, I mean, when I read further on the anchoring and so forth on this stuff, rocking could be an issue, so I wouldn't cheat them any lower, at least than what I'm showing, which is essentially 3 different types: 4x4, 5x5, and 3x3. And there's a 4th type, not shown yet, that accounts for that D plate that is up here at the upper right and down at the lower left. So this footing becomes quite a bit larger here. But A here and A opposite that are going to be that 3 foot. So I have designed these, the ones, and this isn't shown yet, but it will be here in a moment. I've designed all of these. Now if you want me to put these on an actual plan, a paper printed off paper, and dimension down through here what these work out to based on what I've designed, I can do that. Otherwise you could just operate from diagrams of each of these locations and then do your own transference. I did endeavor to, when I come up with, these are the footings that you're seeing, this big 5x5s, 3x3s, etc. When I designed the pedestals for each of these, I have the pedestal aligning, except for this A1 here and this A1 down here, I have the pedestal aligning with the outside of this slab or building, or however that works out there. So once this is over and you want to get back to me, if you want me to move these onto paper where they're all shown all the way around, I can do that. And you can see that in this diagram here. This is the pedestal In this, on C locations, that pedestal is 2'2" by 2'2", and that's largely to make it flush out with the edge of this. It's nice that it gives us that much edge from those anchors, because anchor reinforcement becomes an issue as we go further along here. So that's the C one, and the D one, the same thing. This one is wider still, and none of these, by the way, I'm not accounting for uplift and that sort of stuff. That is in anchor design, and we'll cover that in a minute. But in terms of their bearing, all of their bearing, that's all been accounted for. This is the AD, or the DA, however you want to say it. And then this was the reinforcement with the 3-inch cover based on those footings sizes. This is the reinforcement pattern here. And those are all number 6. I would just keep everything number 6 throughout, even though those A footings are pretty small. I guess you could go to number 5 on those. And I have closer diagrams with details here in a minute. This is the B, that's the 4x4, and that's a 20x20 pedestal. This pedestal here is pretty chunky, but it has that bracing requirement as well as this piece here. So I'm sure that bearing is way more than enough. The pedestal it has a pretty good overlap, or a pretty good edge-to-edge distance from these plates. Now, you can't see what's happening here, but I've located these plates according to the little sub-diagrams they give you. 1'4" to the center line, or 1'2" to the side wall here, and this one is 1'4". And then these have little notations. I can't get close enough for you to see to tell you how far to this edge on each of those. Now here's that A pedestal, and here you can almost see where it says align with end wall here on those A's. This one, the pedestal is here on this 1'4", and I actually widened that out a little bit to 1'6", so you end up with about 8 inches of concrete in front of it, because that's your building line there, your sidewall line. This is your end wall line here. So that is what is happening with A. And of course there's an AD, there's another A down here, not shown. And then this is just these things up close, each of these situations, the 4 different situations, rotated here and there, but the same. This is the A, the 3x3, and that 1'4" goes to 1'6", I'll tell you that. So just know that. I just didn't update this for it. There is the reinforcement, the footing reinforcement, and the verticals coming up. And then you'll have some sort of rings around here, and you're going to have to add some sort of anchor reinforcement that I just don't know enough about to advise you. The B locations, similar thing. There's the C locations and the DA locations. The 4 verticals is all they require here, and I don't know if another one helps. I'm just not knowledgeable enough to know if perhaps you should bring another one over and up here and over and up here. I don't suppose it would hurt. When we get into the design of the anchor bolts, particularly their length and reinforcement for them, because I think it's going to take reinforcement, at least for you to be comfortable, at least for me to be comfortable if it were my building, considering how easy it will be to add the reinforcement once someone who knows what they're doing designs the reinforcement. Nevertheless, I endeavored to find out what I could, and I'm not charging you for that. I'll keep that for my own. But here's a couple of the things that I found out that you can take under advisement. Foundation rocking and rotation may be an issue, especially on isolated column footings. And the final thing is all the different ways this connection can fail, with the conclusion that it's this stuff here. I don't know anything about that. This is the type of anchor that they are specifying for yours, this F1554 grade 36. And I learned enough about this to make some of the calculators, some of the additions and subtractions to know that The way things are laid out now, the size of these piers or pedestals as they're shown will accommodate this anchor reinforcement if it's placed symmetrically, etc. And the only place that's really a close call is at column A, is at pier pedestal A. The rest of the place have enough edge distance and enough distance to the edge that you'll be able to also reinforce those as well. But someone will have to specify, I mean, to my knowledge, if you're going to use reinforcement, maybe even your foundation person has done enough of these to know what they're doing. I have not, because they show this foundation reinforcement and then these hairpin ties or whatever you want to call them coming up and over and down. I don't have the wherewithal even to specify these lengths here. I do this bit here. I come out with a 4-inch anchor, 5-inch on the smallest of them. I come out with a 5-inch. Here it is here. When you do this, when you make this diagram, the height of your effective embedment with this 35-degree angle, that is on that 16-inch wide pier, like that. And so you only get a 4-inch anchor, and I don't know if that's what they're looking for. Again, I'm really lost, but I did want to, since I've done this research, I just want to share with you what I found. I did increase that to 1'6" because a little bit of concrete, it didn't matter, and that gave us a little more edge distance. But I just don't know what to tell you on the length of those. I went to another site and went through a long entry of all various different data and learned a lot about this stuff, but not enough to say I know what I'm talking about when I tell you how to reinforce that. My best guess is that they're going to want some vertical hairpins. I just don't know what grade. Are they number 3, number 4, that go down here and over the top of this and down again. Maybe they want something coming back this way. You can tell that I'm really lost on that portion of it. The thing was very thorough, but you couldn't, because it wasn't a paid program, you couldn't adjust some of this data here. I did what I could, and they warned about the edges here, but you couldn't adjust this either to see how it affected other figures because it's not paid. And they were talking about a 14-inch anchor by 3/4 with an anchor bolt edge distance of 5. We have an anchor bolt edge distance of about 6. Again, though, I think if someone can advise you on anchor bolt reinforcement, you would probably be well served. Otherwise, I'm confident that the footings and the pedestals are fine to hold the load. They won't rock around if you don't put them in. You might have to go lower to get to decent base for those, but if those footings are placed on decent base and are constructed as what I show, I have confidence in those. But I don't know if those beams are going to break out at the edges in a wind event. So that is the best I can do on it. I'm not charging you for any of this anchor bolt research or any of that anchor bolt, any of that beyond once the foundation pedestals and footings were designed. Hopefully at least some of this is helpful.